My name is Piotr Balbier, and as Tomasz said, I'm a front-end developer at NetGuru. So I'd like to talk about a technique in testing methodology that we've used with success in one of our projects, and how it may increase actually the coverage of what we test. So the first thing, how do we actually test? Usually the most standard approach is to specify the cases we want to test, specify what should be the result of some operation that's done, and just basic case-based testing or example-based testing. Quite a new thing is a situation when we know when we should test, what cases we should take into account, but still it's quite difficult what should be the result. And for example, that's widely used in testing with Jest library, and it's called snapshot testing. But there's also a way when we actually don't know which cases are important, we don't know what should be the focus of a test, but we still can test something. There still can be something that will be known about the expected result. And it's called generative testing, or a little bit narrower category, property-based testing. So what it actually is? So it's coming from functional programming world. The first, actually the oldest implementation I know is QuickCheck for Haskell. And it all boils down to generating random data, random inputs, in order to find the simplest data set, the simple case that makes the test fail. So it's actually testing arbitrary data in 3 steps. First, we have to build the data, specify them in a way, test, run the actual tests, and the most important part, though not all libraries for generative testing support it, is shrinking. And there's a concept called arbitrary. Okay. I prepared 2 small files to show it. I use here a library called JS Verify, which is probably one of the, if not the most used library for generative testing. And it provides a set of primitives. So we can, for example, generate a random natural number. I have some helper function to do it. And if you run it, it returns you, in this case, 5 random numbers. The same can be done with arrays, which are, let's say, derivative type. It's array of something. In this case, oh, didn't save. And in this case, an array of string. What happens here? Okay. And at the terminal at the right, you can see a few, actually 5 randomly generated arrays of strings. And there are also a few other helpful tools like arbitrary records, which can create an arbitrary object. And those generators have some specific inner workings, let's say, that generate data in, let's say, uniform way. You can combine those arbitraries to build bigger data, bigger structures. And actually, all that's generated is then fed to a actual test. Usually it's called property. And what it is actually preparing the success criterion. The success criterion for which the test should actually pass. So I'll just need to run the test. OK. And remove this. Yeah. So the simplest property that can be that is possible is just, in this case, I have some record that has that should have some property called stop. And what it actually does, it's running a set of, by default, 100 tests that takes 100 randomly generated records and checks for the existence of such a property. If it fails, for example, we can do a little bit broken record. And it's OK, I just changed it. OK, so that didn't work, I believe, somehow. OK. It happens. OK, never mind. So, quite a useful feature is the shrinking that I've said earlier. For example, we have a sorting function. And we're testing for if some sorting function is stable. What does it mean? Stable sorting is an algorithm of sorting is stable when, regardless of the initial order of the elements, after sorting, it's all the same. So we have such a bit broken sorter function. And as we can see at the right pane, it failed after 9 tests. So it actually stops at the first failing test and then tries to find the simplest case for which the problem still occurs. In this case, it shrank the data set, which was initially an array of actually any number of records, and it shrank it down to array of 2 records that still failed this presumption. And when we, OK. If we fix it, this record, this data structure has to be also sorted according to another property. It would work, it would pass. And such shrinking is actually a way to find an edge case. Because usually the edge case is the simplest to debug, the simplest to fix, and then we can extrapolate it on to another example data. And how it's done, so mostly it's arithmetic operations on numbers and some manipulations on collections, such as adding, removing properties or elements, shuffling the order. And for example, quick check has some magic inside that makes it a little bit more complex, but still it all boils down to a specific order of arithmetics and collections and operations on collections. So to summarize, to be honest, we have thousands of test cases, even if the default is 100. Why is that? Despite it's a little bit low on in the happy path, when some test would fail, we can dig deeper. The shrinking does usually finds a few hundred, sometimes more cases that are failing, and presenting you the simplest one. And you are not obliged to do only one set of tests. You can still do some specific, going through specific paths in a function. So yes, here's a case from one of our tests that we use in an application in one of our projects in the company, and it found an error after only one test, and then it found that 746 another failing cases, and it presents a counterexample, which is this failing case. In this case, it's just 3 dots, but in the original printout, it was actually the whole object that was failing. So as I've said earlier, this shrinking may help you to find edge case dissections, to find edge cases for functions or for some algorithms. Some generators of arbitrary data generate some edge cases. For example, some of them test for 0 every time it's checking for a natural number. And in almost every case, it finds an edge case, not all, but at least one. And this method is quite flexible. Arbitraries, those data schemes for testing, can be, as the name suggests, arbitrary. You can build actually any object, any data structure. For example, JSVerify has one generator that can generate actually anything that can be serialized into a JSON. The condition that's checked, it can be actually anything that returns true or another truthy value as the result. And even within, we can still test separate cases or test for separate cases in objects. For example, we have to test that when this object has this property of that concrete value, it's something we have to focus on, and in this way we can just run another hundreds of tests checking this, and also other cases for the other properties. As every method, it has, of course, some disadvantages. One of the biggest is you should actually know what you test, because it's usually on a bit higher level of abstraction. You do not test specific cases, but you test whether any data can fit the requirements. So actually, it's rather like a testing properties in terms of mathematics equations, rather than testing concrete data for concrete values. And sometimes can be easy to miss. And what I would like to say by that is that some properties that may seem good, well written, actually test something else that is outside of the scope, what the test is designed for. As it comes from the functional programming world, it was written and designed for pure functions, because then they are stable, and there's referential transparency involved, so it's not possible that some side effect would occur, some random issue. And there's also it's also good for functions that have quite simple domains. For example, arrays is a single parameter, an object with quite few properties. Because actually it tests at most hundreds or thousands of cases each time. But when you use something like a continuous testing, for example, when jest tests runs all the test suits after a file is modified. You actually can run tens of thousands of tests, but not always for the same part of the code. But some of those issues with side effects can be fixed with using mocks, but that's not always a reliable idea. And there's also unrepeatability. It's random data. And what's more, if you go through the happy path without any errors, it tests only 100. And on each case, on each run, it's another 100 of cases. But there are some frameworks for generative testing provide seeds, so that you can run the failed test once again by providing the random generator seed that would generate the same data, and it's possible to just debug it any time, any number of times you like. And another case is time. All tests take time. In our case, we had 78 properties, so like tests in terms of generative testing. It increased the total time of testing, of running it on continuous integration from 50 seconds to 75. But yet it just covered actually all of the cases for what was tested. The system under test was a data mapper that was mapping from one quite complex data structure, an object coming from another source, to a DTO that was to be sent to the server, to the API. And each failing property in each test increased the whole run by 1 or 2 more seconds due to the shrinking that needs more time. So in the JS world, we actually have 3 main implementation of this method. There's JS check from Douglas Crockford. It does not have an ability to shrink data, but still is a very simple library and very easy to go through the source code. And then JS verify that I've shown a bit that's maintained by Oleg Renras. It's quite well maintained, though it has some problems, for example, with typing. And there's fast check from Nicolas Dubian, which is quite a new library. A colleague of mine showed it to me quite recently. It's written completely TypeScript and has full support of typing, so you can be sure you use the right structures within the tests and outside of them. So the title, testing more with less. When it comes to generative testing, it's actually testing more cases, more data inputs, with less code written, because each single test can make it test from hundreds to thousands cases. And when it comes to the coverage, there is let's say like a holy grail for many developers is the code coverage, but still there's such a case and such a situation that even if the code coverage is very high, actually the coverage of every possible cases is very low, because we're only checking 1, 2, 5, 10 cases. So thank you.
Thank you very much for the talk. Believe it or not, there are questions. Yeah. There's lots of questions.
I know.
So we're going to spend the next 2 hours here. Is that okay?
So without lunch?
Yes. Oh yeah. Speaker of lunch break. After the Q&A, please don't go away, because ZB will go on stage and explain how the lunch is going to actually work.
Okay. Yeah. So let's pause for a second while we're still here. I hope you can also hear me if you're out in the hall. That's what I'm told this microphone does. We're going to have lunch in 2 rounds, and your IDs, your badges, have the indication of which round it is, bottom left side. This is assigned at random. It's a suggestion. If you want to spend less time queuing for lunch, follow that suggestion. The agenda has times for both rounds of lunch. So we start 12:45 with the first round. And there's 2 rooms with lunch for you on level 1 and 2. If you exit and go straight next to the registration, you can follow the signs. And remember to have your lunch ticket handy. I guess that's everything. Yeah. Back to questions. Sorry for the interruption.
Yeah.
So how exactly do you know that shuffle function is stable to test sorting stability?
Shuffle function, it's actually doing a permutation on an array, and that's the case for stability, checking if some permutations cause it's rather not causing but exposing the issue. So actually on each run a new array is generated, a new permutation is generated, and in such a case, it's actually very, how to say that? It's actually quite a significant probability that on at least one of those tests, on at least one of those runs, there's an error code.
Okay. Wow. Okay, so speaking of probability and stuff like that, there's this ongoing discussion for the last, I don't know, 25 years or so. Should you aim for 100% code coverage or not? And you are the judge. You will get to decide.
Okay, in my opinion, it's not how many percent of code coverage there is, but actually how confident the tests are. So you can write tests that test actually nothing but still make it 100%, and there are some cases that you may have 5% of code coverage, but for example, most of the possible bugs are taken into account, are taken care of using type checking or validations.
Okay, there was one more question that was heavily upvoted to the top, is about, can you test, for instance, components this way? I know, like React components that you kind of run for every single combination of possible properties.
Yeah, actually, in that case, the data generated would be the props. You can provide specific conditions, how the props should be generated. And actually, a colleague of mine was testing fast check with such a thing. As far as I remember, he was testing some kind of quiz questionnaire that mounted into a DOM and prepared all the answers, what are the correct answers, and check in each and every case when the correct answers are checked, says the result is 100%, and so actually it's not a way to test functions. It's function in a more abstract way, because a function can be also something that generates a component, runs some operation, and then returns its state.
Okay. The last one before we finish, I'm not trying to go through only the most upvoted ones. By the way, do remember that you can always ask a question to on Slido, I suppose also during the lunch break. And the last one, why testing has to be so boring?
Testing is usually considered to be boring because for many developers, especially younger developers, it's usually they think, from what I observed, that the goal of writing software is to write software. So they often forget that writing good software is also making its quality. Okay, so good.
It actually works.
Yeah.
Okay. Cool. Thank you very much.